Bismillahirrahmanirrahim. This is teacher Iman explaining solving quadratic equations second degree in complex number set. We're going to choose the best alternative. The first equation is the two solutions of the equation 4z squared plus 25 equal to 0 are. You can solve it in two different ways: factorization or moving this 25 to the other side. And I will do one of them. 4z squared equals negative 25. Divide both sides by 4 and you can get z squared equals negative 25 over 4. You can take a square root for both sides and that will give you plus and minus a quadratic equation with negative 25 over 4 under the root. You can have z equals plus and minus 5 over 2i, which can be the second choice, the third choice, which including 5 over 2i and negative 5 over 2i. In question 2, the question asks you to find the two solutions of the equation z squared plus z plus 1 equals to 0 are. If you think to factorize this quadratic equation, you can't easily, because you can't find two factors will give you 1, and two factors, if you add them, you can get 1. So you are able to use the quadratic formula, which is including z equals negative b plus and minus square root of b squared minus 4ac divided by 2a. Negative b means that you're going to use a and b and c from the equation, which are a for 1 and b is 1 and c is 1 from here. And that will be easy if you be sure that your whole equation is equal to 0. Now you can replace them easily in the formula by writing 1 squared minus 4 times 1 all under the root divided by 2. You can get z equals negative 1 plus and minus square root of 1 minus 4 divided by 2. If you will subtract them, you can get easily negative 3 over 2. That means z equals negative 1 plus and minus root of 3 stays under the root because it is not a perfect number. So it is irrational, and this negative goes outside to be I in the complex number. And that's it. And that all divided by 2. So you can choose easily the second choice, which is this one, including negative 1 plus and minus root over 3i over 2. In the third question, the two solutions of the equation z squared minus 2 root of 2 z plus 4 equal to 0 are. It is hard to be factorized also, this quadratic equation. So you're going to use the quadratic formula again. But you have to be sure how much is a, which is 1, and b, which is negative 2 root of 2, and take care about this negative, and c, which is 4, and be sure that your equation is equal to 0. Now, negative from the rule and negative from the b, both together will give you positive 2 root of 2. Plus and minus from the formula square root of. If you square root 2, you will get 4. If you square root of 2, you will get 2. That all minus 4 times a, which is 1, and c, which is 4, all under the root divided by 2 times a. Z equals 2 root of 2 plus and minus square root of 8 minus 16. all divided by 2. Then z equals 2 root of 2 plus and minus square root of negative 8 divided by 2. Then z equals 2 root of 2 plus and minus 2 root of 2 after simplifying 8 to 4 times 2 and taking the negative outside the root to be I in complex number divided by 2. Now I can split the fraction to be 2 root of 2 over 2 plus and minus 2 over 2 root of 2i and cancel these two and these two together. That will give you root of 2 plus and minus root of 2i. Then if you're going to take root of 2 as a common factor, you can get 1 plus and minus I. And that will let you choose a choice number 1, not a choice number 2. In question 4, the solution set of the equation z square plus 2i z dash minus 1 equal to 0 is can be solved easily by also quadratic formula. Now we have z dash here, so it's better for you to replace the solutions that he give you, but be smart when you are replacing. You can see that you have I everywhere, so don't replace it because it won't make a difference. But you can think about the different roots or solutions. Like, for example, in number 1 you have 2 minus I here and 2 minus I there. If you replace one of them instead of z as a solution and give you 0, that means this is the choice and you can cancel 2 and 4. Let's try. Let z equals 2 minus I will substitute it where in the equation, like this exactly. 2 minus I all square plus 2i times 2 plus I, because it is a conjugate, minus 1 all equals to 0. I will use the perfect square rule in expanding 2 minus I square by getting 4 minus 1, this is for real part, plus always between the real and imaginary, 2 from the rule times the real times the imaginary part, and then think about expanding this 2i by the first bracket with 2n plus I, and you can get easily plus 4i and plus 2i squared, which can give you minus 2 minus 1 all equals to 0. Try to expand the brackets and evaluate them. You can get 3 minus 4i plus 4i minus 3 all equals to 0. If you will get 0 from the left side equal to the 0 to the right side, that means your solution is true and you chose the right root. I can see that 3 with negative 3 can be cancelled, and 4 with negative 4i will be cancelled. So I can get easily 0 to the left equal to the 0 to the right. So I can choose number 1 or 3. Then I will cancel 2 and 4 easily. I need to focus on the third root now, which is negative 2i or positive 2i, like this exactly. Maybe this one or this one. So if you will replace one of them, and you can get a right solution, so you can choose it. Let me check this one. If z equals negative 2 and negative I, let me substitute it again. I can get negative 2 negative I all squared plus 2i times negative 2 plus I all plus or minus 1 equals to 0. If you're going to use the perfect square rule, you can get 4 minus 1 again, then plus 2 times negative 2 and negative 1 and I. Take care about the negatives everywhere. Plus 2i times this negative 2 will give you negative 4i, and 2i times I will give you negative 2, negative 1 equals to 0. Add them and evaluate them. If you will get 0 equal to 0, so this is the solution. 3 minus, by minus will give you positive 4i, minus 4i, minus 3. You can cancel them easily and see that 3 here and there will be cancelled, and positive 4i and negative 4i will be cancelled, so you have 0 here equals to 0 there. So this is the solution. So I can choose easily the first one, not the third one. Good luck for you all. Thank you.